Alright, so I'm going to explain integrating to get natural log. So, we start with this idea up here that the integral of dx over x is equivalent to the natural log of the absolute value of x plus c. So we spent last class differentiating ln to get to this integral, and now we're going to kind of go back. Alright, so here's an example. Integral of x dx over x squared plus 5. Now, we basically are adding this rule to everything else we've already learned. Alright, so u substitutions, for instance. So in this case, you're going to want to make u equal to x squared plus 5. And when you do that, of course, your du is 2x dx. Okay? So this is going to help us because we can put the 2 in here. Of course, we put a 2 on the inside. To go with our dx, we need a half on the outside. So those compensate for each other. And so now we have this integral, 1/2 integral 2x dx over x squared plus 5. Now I can substitute in for my u's. The half is still out here. Here's du over u. And so now it's in a form that we can deal with more easily. So we've got 1/2 ln of absolute value of u plus c. Now, of course, if you start with x's, you want to finish with x's. So we put the x squared plus 5 back in. The last thing I would say, and you're going to see this in the textbook sometimes, I'm not a real stickler for this, but it is more correct, is to just take off the absolute values, because you know x squared plus 5 will never be negative, and so having absolute values is redundant. All right, I don't want you to be so sensitive to it. You put absolute values on everything all the time, because that's not always correct either. But just to see that you don't really need it here. Okay. All right. Now, another tricky thing about this, because of the natural log and log properties, is the idea of getting equivalent answers. So let me show you what I'm talking about there. If you get an answer such as 1/3 ln of 3x plus 2 plus c, okay, that answer is equivalent to ln of 3x plus 2 to the 1/3 plus c, because you can take the coefficient and put it inside as an exponent. Now that one is not particularly difficult to see, I think. What's a little trickier is this one down below. Starting with the top expression and basically factoring a 3 out. So I factor a 3 out of 3x plus 2 to get me to here. Okay? Now, this is a log of a product. It's a log of 3 times x plus 2/3. So I can split the log of a product into a sum of 2 logs. So it's 1/3 ln 3 plus ln x plus 2/3 plus c. And the plus c is a key thing here, because c is just some random constant. Well, so if you take 1/3 times ln 3, which is just some other constant, and you add it to c, that's just a different random constant. So basically, I can ignore it. And so I get all the way down to here. So notice that this says c1, whereas this says c, because strictly speaking, they're different random constants. But the main idea is that if you did a problem that came up with this as an answer, the 1/3 ln 3x plus 2 plus c, you might have an answer in the back of the book, 1/3 ln x plus 2/3 plus c, and they're the same thing. Okay, these really are equivalent answers. Okay, a couple more things to go over. This is an example where u substitution cannot be done immediately because this is an improper fraction in your integral. It's improper because the numerator is of a degree equal to or greater than the denominator. And so in this situation, the first thing you have to do is divide. So you'd have to use long division to do this. Okay? You have to do x squared plus 1 into x squared plus x plus 1. And when you do that, you would come up with your remainder is 2x. So 2x over x squared plus 1. This is your quotient. So now the integral of 1 is just x. And the integral of 2x over x squared plus 1, well, we just did something just like that, didn't we? It's over here. Do I need the half? No, I don't need the half. Let's take a look. Okay. So what I should have is, this is my division. And so in doing that, I still have my 1, so I still have the x, but the correct part is over here, so I wouldn't have the 2. So what I would do is I need to have the 2, which is why I would have had to put the half out front. So ends up being the correct answer, but I got there the wrong way along the way. Okay. Another example 7, is sort of a ln within a ln. We have integral of dx over x ln x. And so if u is ln x, then du is dx over x. And so I rewrite this as du over u, which is a ln u plus c equals a ln of ln x plus c. So it's a ln within a ln.